In this video, we're going to make our NPCs react to noise. Here, if I press V, I'm going to whistle, and the NPC is going to come to the position of the noise, then investigate. If nothing out of the usual has been sighted, then the NPC will go back to their guard post. We're going to split noises into two types. First, the common noises, then the combat noises. So a combat noise could be a firearm discharging. So if I shoot, the NPC is going to come at me, but in an alerted state. So I'm going to shoot, and now you can see that the NPC is running and aiming his gun. He's going to investigate like he did before and go back to his guard post if nothing is out of the ordinary. The enemy can also react to bullet impacts, so I'm going to get a little bit far so he doesn't hear the gunshots and only hear the bullet impacts. So I'm going to hit the wall near him, and he's going to investigate the source of the noise. In the code, I don't consider bullet impacts as combat noises, so he's just going to investigate in a relaxed state. Alright, that's the result that we want to achieve. Let's get coding. Let's start by creating an input action that will allow the player to whistle using the V key on the keyboard. Let's go to Project Settings, then Input System Package, and in the list of actions, I'm going to add a new button called Make Noise. So the action type will be button. As for the binding, I'm going to bind it to the V key on the keyboard. Let's go to our player control script. So let's go to Scripts, Third Person Controller, then Player Controller. Let's scroll all the way down to Input Callbacks. We're going to add an onMakeNoise method that takes input value as parameter. And in it, we're going to invoke the say action on the NPC with some text. So here I'm printing whistle. And we're going to call a method called makeNoise on our NPC, and we're going to give it a noise info. So these are the informations on the noise, and we're going to define it right now. Let's go to Scripts, NPC Sensors, and here let's add a new folder. Let's call it Hearing. Here we're going to create a noise info struct. In the struct, we'll have a reference to the owner of the noise, a noise type, the position of the noise, and the radius of the noise. As for the noise type, it's an enum that describes the different noise types of the game. So we have common noises, gunfire, and bullet impact for now. And the reason why I added a reference to the owner of the noise is because we don't want NPCs to react to their own noises. For example, it would be absurd if an NPC fires a gun and then gets surprised by the sound that it makes. So it doesn't make sense. Back to our player controller. We're going to invoke makeNoise with a noise info where the position is set at the position of the NPC, the radius is set to 10 meters, and the noise type is set to common. So let's define the makeNoise method in NPC. First, what I'm going to do is organize these properties in a region. So let's remove this. Let's create a region called Sensors, and in it we'll have the reference to the sensor and the sensor position. Let's create the makeNoise method here with the noise info as parameter. This noise info may have come from any source. So just to make sure that the owner is this object, we're going to set owner to this. Then we're going to broadcast the noise to all the listeners in the noise radius. But we're not going to do that here. We're going to create a class called noise system that we're going to add to the scene. It's going to be a singleton. So let's create the noise system class. Let's go to our hearing folder and create a new class called noise system. We're going to need a layer mask for the character layers. We're going to target the layer that contains our character controllers. Then let's create a static instance property with a get and a private set. Then let's define the makeNoise method. First, we get all the colliders using overlap sphere. We're going to give it the noise position, the noise radius, the character layers, and we're going to ignore collisions with triggers. Then for each collider, we're going to look for a component in the parent of that collider. We're going to call this component iNoiseListener, and it's going to be an interface that we're going to define shortly. And we're going to invoke a method called onNoiseHeard on that listener. Of course, only if that listener is not null. Now let's create this interface. It's going to be very simple. So in the same hearing folder, let's create the interface. It's going to have the onNoiseHeard method, and it's going to take the noise info as parameter. Back to our noise system, In the awake method, we're going to set instance to this object. And by doing this, we've made noise system a singleton, since we can access the instance globally anywhere in our code. Back to the editor, let's create a noise system object. So we're going to create an empty object and call it noise system. I'm going to put it at the top below the UI manager, and I'm going to add the noise system script to it. Then I'm going to set the character layers to nothing, then click on character controller. And this will make our NPCs the only objects capable of listening to noise, which will make the physics.overlapSphere code very fast. Okay, now we've made our NPC capable of making noise. Let's make it capable of hearing the noise. Let's go to our NPC sensor. We want our NPC sensor to be able to listen to noise. So we're going to make it implement the iNoise-Listener interface. So to keep things organized, I'm going to create a new region here. Let's call it hearing. And let's implement the iNoise-Listener interface. Okay, let's write the onNoiseHeard method. First, we're going to ignore our own noises. So if noise.owner is the same as our NPC reference, we're going to return. Now, when we hear a noise, we need to store the information on that noise. So let's define a few properties. Let's start with a Boolean noise heard with a get and private set, a vector tree noise position, a noise type of type noise type, and set to common by default. We're also going to record the time that we heard the noise. And let's define time since heard noise, which will be a getter for time.time minus noise time. We're also going to draw a sphere gizmo at the position of the noise. So for that, we'll need a noise gizmo color. And just for the sake of debugging, let's create a multi-line string where we're going to print the informations on the noise. Okay, let's go back to the onNoiseHeard method. So here we're going to set noise heard to true. We're going to set noise time to time.time. We're going to set the noise type. As for the position, we're not just going to set the position to noise.position because we need the noise position to be on the nav mesh. So we're going to use navmesh.samplePosition and we're going to give it the noise position, and we'll keep the max distance at 4. And for the areas, we'll set it to all areas. If we hit a position on the nav mesh, we're going to set noise position to hit that position. Otherwise, we're going to set noise position to noise.position. Okay, now we're going to update this here in debug string, and we're going to display the noise gizmos. Let's do it in separate methods. We're going to have an update hearing method and a draw noise gizmos method. Let's unfold the Unity methods region. So in here, in the start coroutine, below update detected entries, we're going to update hearing. Okay, then let's go to the gizmos method in here. So we have the onDraw gizmos. Let's go to the bottom of the method. And here we're going to call draw noise gizmos. So let's go back to these methods. Let's start with draw noise gizmos. If noise heard is false, we're going to return. Otherwise, we're going to draw a sphere at the noise position with a small radius, say 0.2. Now let's write the update hearing method. If no noise is heard, we're going to set hearing debug to none and return. So the reason why I made this method is not only to update the hearing debug string, but also I want to implement something similar to the detection entries, except here we only have to keep track of one noise, but we want to forget that noise after a while. So we're going to use the entry expiration time variable. So we're going to check if time since heard noise has exceeded the entry expiration time. Then we're going to call a forget noise method. Let's define it here. So this method is very simple. It's just going to set noise heard to false, and we're going to make it public in order to use it from outside the script. So now let's update our hearing debug. I'm going to use a $sign in the string. This will allow me to write code between brackets. So here I'm going to print the time since the noise was heard, but I'm going to round it. Let's call round to int. Let's say heard noise, this number of seconds ago. Let's add a carriage return with \n\r, and let's print the noise type as well. Now let's go back to the editor. So this sentry will go to the guard post in here, but in fact we're going to remove the guard post so the sentry will stand in place. Let's bring our player closer. That way we can test right away. I'm going to click on the sentry and then right-click on the NPC Sensor Inspector properties to keep it open at all times. Then I'm going to make sure draw gizmos is set to true. And for the noise gizmos color, let's choose a purple color, something like this. Then let's have gizmos enabled in the game view. So I'm going to apply this to the NPC, apply to prefab NPC. Then let's run the game. Okay, so this is my player. Let's make sure I'm on the blue team. I don't want to trigger the combat behavior of the sentry. Okay, now I'm going to press V to whistle. And as you can see, the NPC has heard the noise. So this is the noise position in the purple sphere. And the noise has been heard 15, 16 seconds ago, as you can see. So the NPC is updating the hearing debug string. And now when it reaches 120, the NPC will forget about it. So I'm going to cut the video and resume right before the NPC forgets the noise. Okay, now we are at 110 and the NPC will soon forget about the noise. 5, 6, 7, 8, 9, 120. And as you can see, the NPC has indeed forgotten about the noise. Okay, so our code works. Now all we have to do is modify the behavior tree of that sentry in order to react to the sound. Okay, we are in the sentry behavior tree script. We already created an investigate noise branch in the main FSM. So let's control click it. This is just an idle action that we used as a placeholder. Now we're going to write the actual branch. Let's create a sequence that we're going to return. Let's define the utility override func. We're going to get a reference to our sensor using npc.value.sensor. If sensor noise heard is true, we're going to return 5. Otherwise, we'll return a utility of 0. This sequence will be quite simple. We'll get the noise position and the NPC will go to it. Then we'll look around and then forget about the noise. So we're going to need a bunch of actions and conditions. Let's go to scripts, NPC tasks, then actions, sensors. Let's create a new folder called hearing. And in here, we'll create a new class called getNoisePosition. It's going to be an NPC action. Let's add a shared vector tree noise position. And let's define a couple of constructors. Then let's override the onUpdate method. So in here, we're simply going to set the value of noise position to sensor.noisePosition and return success. So this is a very simple action. Let's add another action called forget noise. This is also a simple NPC action that we'll call sensor.forgetNoise and return success. Let's also create a make noise action. So this will have a shared float radius and we'll call make noise with the position of the NPC and the radius. We will not use this for now, but you never know, we might need it later. Let's create some conditions. Let's go to the conditions folder, then sensors, and let's create a hearing folder. Let's create a heard noise condition, which will return success if sensor.noiseHeard is true and failure otherwise. Now let's go back to our sentry behavior tree. In the create investigate noise branch method, let's create a noise position shared vector tree. Let's display a question mark on the speech bubble. Let's disable amin. Then let's add our get noise position action. Then go to it. Then we're going to add a look around sequence here. Then forget about the noise. We created the create look around branch earlier, which has a repeater that will repeat between 3 and 5 times. And in this repeater, we have a sequence where the NPC will look at a random angle, then wait. Okay, so with this sequence, our character is able to investigate noise. Okay, let's do a test. I have the behavior tree viewer of the sentry behavior tree here with the engage, investigate hostile, investigate noise, and idle branches. So we're going to make a noise and see how the NPC switches to the investigate noise branch. So let's press V to whistle. The NPC went to the noise position and now he's looking around. Then at the end of the looking around branch, he's going to forget the noise and go back to the idle branch. So now we have a problem here. Let's say the NPC is investigating the noise, but if I make another noise, he's going to be unreactive. So we need the NPC to interrupt the investigate noise sequence when a new noise is heard. So we already implemented interruptions for higher priority tasks, but now we need this sequence to interrupt itself. So we need to implement self-interruptions, and the conditions for that self-interruption will be if a new noise has been heard. So if we are in the investigate noise sequence and the NPC hears a new noise, then we're going to interrupt the sequence itself and restart it. So we've created the heard noise condition. Now let's create a heard new noise condition. So let's create the condition here, heard new noise. We're going to override the onUpdate method. If sensor noise heard is false, we're going to return failure. And we're only going to return success when sensor.time since heard noise is lower than a threshold. So for the threshold, I've chosen a value of 0.1 seconds. So if time since heard noise is lower than 0.1 seconds, we'll return success. Otherwise, we'll return failure. So we'll use this condition to interrupt this sequence. So let's go ahead and implement self-interruptions. So let's go to scripts, task system, base, then composite. And here at the top, we have a Boolean interrupt lower priority. We're going to add another Boolean interrupt self. Let's scroll down to the conditions methods region. I'm just going to fix a small issue. So in here, if condition is empty, we're going to return true. And in the evaluate interrupt conditions, if interrupt condition is empty, we're going to return false. And we're going to need to define the empty property in the composite condition. So let's go to composite condition, and below the evaluation mode, we're going to define a public bool empty that will return true when conditions count is 0. Okay, let's go back to the composite script. Actually, we're done here. So we're going to go to the task script. Let's go to the static task manipulation methods, and let's scroll all the way to update composite. So in here, after this block and right before we call onUpdate, we're going to check if task interrupt self is true and task evaluate interrupt conditions is true. If both of these conditions are met, we're going to restart the task and return task status running. Okay, that's all we need to implement self-interruptions. Let's go back to our behavior tree. So behavior tree, script, sentry. Then in the investigate noise branch, in the sequence inline definition, we're going to set interrupt self to true. Then we're going to call set interrupt conditions, and we're going to give it a new instance of our heard new noise condition. So this will allow the NPC to interrupt the investigation sequence if a new noise is heard. So let's test it. Okay, let's press V. The NPC is investigating the noise. Now let's press V again. So as you can see, the investigate noise sequence is being interrupted whenever I press V to make a new noise. Doing it like this will allow the player to abuse NPCs a little bit. So we're going to add some fixes. First, we're going to prevent investigation if the noise comes from a visible NPC. Then we're going to make a noise whenever the player shoots or when the bullet hits a wall. And what we'll do is also differentiate between common noises. So for example, whistling is a common noise, but shooting a rifle is a combat noise. So we're going to differentiate between the two, and we're going to create a new investigate sequence, but this time is going to be about investigating combat noises. Let's go back to our NPC sensor. In scripts, NPC, sensors, then NPC sensor. In the onNoiseHeard method. So first we ignore our own noises, but we also need to ignore noises coming from visible NPCs. So we're going to say if noise owner is not null and is visible noise owner, then we're going to return. So if the owner of the noise is visible, then we already have mechanics in place to handle that. So if the owner is an enemy, the NPC will switch to the combat branch. And if the NPC is an ally, then what's the point of investigating that noise at all? Now let's go to the properties. Let's add an isCombatNoise property that will return noiseSystem.isCombatNoise with our noise type as parameter. So we're going to define this method in the noise system. Let's click on this generate method, and we're going to control click it. So it's going to be a public static method and will return true only when noise type is equal to gunfire. So gunfire is the only combat noise that we're going to consider for now. Of course, in the future, if we add some other combat noises, like for example, an explosion, we'll need to update this method and add the condition here. Okay, now let's go to our conditions. So in NPC tasks, conditions, sensors herein, let's modify these conditions to take into account the combat noise. For example, if we want the heard noise condition to trigger only when we have a combat noise, so we're going to define a shared bool only combat noise, and we're going to add a condition in the onUpdate. So if only combat noise value is set to true and sensor is combat noise is false, then we're going to return failure. Otherwise, we'll return success or failure depending on the value of sensor.noiseHeard. And we'll do the same in the heard new noise condition. So let's go to heard new noise. Let's define an only combat noise shared bool. In the onUpdate, of course, if we didn't hear a noise, we're going to return failure. And below this if statement, we're going to say if only combat noise value is true and sensor.is combat noise is false, we're going to return failure. And below, we'll keep the same code as before. Okay, now let's go back to our sentry behavior tree. So what I'm going to do is I'm going to copy this method. So let's copy the create investigate noise branch method. Let's copy it and paste it below. So I'm going to rename it to investigate combat noise branch. In the sequence, I'm going to call it investigate combat noise. It's also going to interrupt itself. In the utility override method, we're going to check if sensor noise heard and sensor is combat noise. But instead of 5, we're going to return 7 just to place it above the regular investigate noise branch. As for the interrupt conditions, we're going to add only combat noise here. So we're going to use an inline definition with only combat noise set to true. And in the investigation sequence, we're going to set aim to true this time. In the go to action, we're going to set run to true. So we want our NPC to aim and run. Then at the end of the sequence, we can set aim back to false. Okay, now we have an investigate combat branch sequence. Let's go to the create behavior tree method. And here we're going to add our investigate combat noise branch. Let's put it above the investigate noise branch. So in here, I'm going to say investigate combat noise branch. Okay, now we have a branch to investigate combat noise, but we'll actually need to make that combat noise, okay? So let's go to our gun script. Let's go to scripts, NPC, combat, then gun. Let's go to the try shoot method. So if time.time is superior to next shoot time, we're going to make our combat noise here. We're going to call the make noise method on the NPC with a noise info where position is set to muzzle.position. Radius is set to 10 meters, and type is set to noise type.gunfire. Below the try shoot method, let's create an on bullet impact method, which takes a raycast hit, and we're going to call make noise on our NPC with the position set to hit.point, radius set to 10 meters, and type set to noise type.bullet impact. And we're going to use this method in our spawn hit scan projectile method. So let's control click on spawn hit scan projectile. So in here, after doing our checks, so after making sure that we ignore the hits on our own colliders, so we're going to invoke on bullet impact with the raycast hit. Okay, that's it. Now let's test all of these changes. Okay, so here's our NPC. He has the investigate combat noise sequence here and the investigate noise sequence here. So now let's try to go in front of them and let's hit V. So I'm whistling. But the NPC doesn't investigate the noise because he's seeing me. But if I hide and then press whistle, so he's too far. So let's go back. Let's go behind them and hit V. So he's going to investigate the source of that noise. So now I'm going to shoot. But I've noticed something. So if we shoot and we have a bullet impact, the NPC will go to the bullet impact just because it is the last noise that has been heard. And that's an issue. We should prioritize the combat noises above the common noises. So let's go back to our NPC sensor in script NPC sensors, NPC sensor. Let's go to the on noise heard method. So we're doing some checks here. Let's add another if statement here. So we're going to ignore common noises if a combat noise has been heard recently. And by recently, we're going to define a number of seconds. For example, let's say if time since heard noise is lower than 5 seconds and the current noise is a combat noise, but the new noise is not a combat noise. So in this case, we're going to return. So in other words, if we have a combat noise that has been heard in the last 5 seconds and a new common noise has been heard, we're simply going to ignore it because a combat noise is generally more important. And that should fix the issue. So I'm going to shoot at the floor and the NPC is going to prioritize the noise of the firearm discharging rather than the bullet impact. So let's test it here. I'm going to shoot. So as you can see, the NPC is coming to the position where I shot the gun and he's coming while aiming. So he's in the investigate combat branch. Let's go a little bit far. And now I'm going to shoot next to him. Now the only noise he has heard is the bullet impact. So he's going to investigate it in a relaxed state. From the player's point of view, it's a little bit easy to abuse the behavior of this NPC. But you have to remember that this NPC considers us to be friendlies. If we were enemies, for example, let's go and set the faction of the player to the red faction. I'm going to go here, then shoot. Then the NPC will come running. He has to be within 10 meters. So now the NPC is in the combat branch. Okay, so in this episode, we've added the ability to hear noises for NPCs and also react to these noises. I hope you found this episode helpful. Thank you for watching. Remember to subscribe, share the playlist with a friend. Leave your comments down below if you have some issues. I'm going to do a Q&A session soon. So if you have questions, please ask them below so I can answer them all in a video. Okay, so I'm going to see you in the next video. Until then, take care.